So, hello everyone. I'm Luca, and today I'm going to talk about heat attacks. Most of you know what I'm going to talk about. So, what I will show you today is, despite the usual heat attacks, I will show you some new offensive devices were developed lately last year, and we'll see what we can achieve with these new generation of heat attacks. Which will be the intakes of this presentation? Well, after this presentation, you will be even more paranoid about USB devices. You will learn about new tools for pranky colleagues, phone customers, or scare CISOs, because that's what we like most. You will forget about rubber ducky and bash bunny, and most importantly, you will not trust anymore USB dildo and palm breasts. So let's make a short recap of what are HID devices, despite the D of HID is already device. Human interface device, according to Wikipedia, is a type of computer device usually used by humans which takes input and gives output to humans. Kind of dumb definition, but that's Wikipedia. What we know about each HIDs? We use every day keyboards, mice, game controllers. And what we also know about that most of the time do not need drivers, external drivers. Windows, OS X, Linux, they do recognize keyboards automatically. There are some corner cases like, OS X is asking you to press some specific keystrokes just to identify the keyboard language. But anyway, usually most of the time are drivelets. What is another feature, an interesting feature of this class of devices? Well, usually are ignored by DLP solutions. I know that there are some solutions like GData that has a USB guard that is dedicated to detect HID attacks, but most of them do not care about HID, human interface devices. They care mostly about flash drives, so you cannot plug it in the next version of Stuxnet, for example. Here is an example of, like 2 weeks ago, I was checking my antivirus solution I had in my corporate laptop, and I cannot give you the name, ESET. And practically, this solution, as you can see, allows to whitelist or blacklist, block USB devices. As you can see in the list, there are plenty of them, but there is only one missing, HID devices. So keyboards are cannot be whitelisted or blacklisted by this solution, which is an issue. And of course, another feature of keyboards and mice is that they are not usually under the antivirus scope. So what could possibly go wrong? We know, most of you probably knows the first generation of HID offensive devices, like the most common and shown also on Mr. Robot TV series is rubber ducky. Rubber ducky was and is a dedicated hardware, which of course can be used in multiple platforms because it depends on the payload. So it's compatible with Windows, Linux, OS X, and so on. Has multiple payloads, has the ability to change VID and PID. What is VID and PID? VID is version ID and PID is product ID. These two identifiers should be univocally identifying a specific type of a specific brand of a device, like HP keyboard blah 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 01 has a specific VID, HP, and product ID is that specific ID of that specific type of keyboard. So in this case, rubber ducky was able to spoof those VIDs and PIDs because some DLP solutions that are blacklisting, whitelisting HID devices can be bypassed by spoofing such ID. The only sad thing of rubber ducky is still the price. It's around 55 euro if you want to buy from US to Europe, and it's kind of expensive. The other solution was a do-it-yourself solution based on Teensy as a hardware part. And from the software framework point of view, we're both open source, Cotilia and PHUKD. And this was the first generation between 2009, 10, 11. The second generation can be dated around 2014, 2015. And these two devices, one bad USB, which was the outcome of a research made by Carsten Knoll and the guys from our SR Labs from Germany. Practically what they figured out that on the market there are existing USB devices like USB flash drives or USB hubs that have a very specific type of controller, like Phison, which can be reflashed. So by reflashing, by hacking the firmware and reflashing it, they were able to turn a very simple and commercial solution like a USB flash drive or a USB hub in a rubber ducky-like. So malicious keystroke injecting device. Another device developed around the same period, 2015, by the NSA Playset guys from US. Practically what they did, they recreated a device, an implant, hardware implant, developed back in time by NSA around 2008, leaked by Snowden in 2013, and the code name by the NSA Tau tool was called Cottonmouth. I will show you later the original leak paper. And practically they recreated it, called it Turnip Skull, and has the same functionality. It was the first kind of USB hardware implant, open source and open hardware, able to, once connected to the target machine, was able to create a radio communication channel. So in that way, an attacker was able to connect to that target, even if it was air-gapped. I will talk a lot about air-gapped. So what is an air-gapped environment for the ones that do not know that? Air-gapped environment is very simple. Imagine a computer, a station, or an entire, well, relatively small LAN that are not connected to other networks. So just imagine a HMI, human-machine interface of a nuclear plant is not supposed, technically, is not supposed to be connected to internet. We know what risk can come out of that. So in this case, this particular implant was the first of that kind, able to bypass these kind of air gap restrictions. The third generation can be dated around 2017 and still ongoing, and is divided into devices. The first one that I was working on, and I will show you in depth, is called Weed Injector. You can see it as a rubber ducky on steroids if you want to make comparisons with something. Instead, the other one, developed by Marcus Mang, called POMP, you can see it as a Bash Bunny on steroids. What they're doing? Well, Weed Injector is a dedicated hardware, exactly like rubber ducky, so not a do-it-yourself solution. Why I decided to design that? Because many pen testers either do not have time to, solve their stuff, play with electronics devices, or either they do not know how to do that. They don't want to spend time in that. They prefer to own like Active Directories and using DevStar and Trends. So yeah. And so practically I designed this hardware. So the dedicated hardware, as Rubber Ducky is able to, is multi-platform, able to spoof VID, PID, because it's important as well to bypass DLP solutions. And the most important part, with respect to Rubber Ducky, it has Wi-Fi. So in this case, the attacker, in one way or in another, as soon as the Weed Injector gets connected to the target machine, the attacker remotely from outside the building or with the call home function, if, of course, he needs to preset an existing Wi-Fi network to connect the Weed Injector and then reach outside, is able to connect remotely to the target machine and inject the payload whenever he wants. Because another sad feature of Rubber Ducky is that you have to run the payload immediately it runs. I mean, as soon as you plug, you can run it. Of course, you can put delay, but you cannot exactly decide at which exact moment trigger it remotely. And another thing, I wanted to keep it cheap. So it's around 13 euro now, because the cost of Atmega 3204 raised. And I'm not getting any royalty, so I just wanted people to get it. People said, oh, looks cool, I want it. So I just asked a manufacturer in China to do it. POMP. POMP is another cool device. The only expense here is just the Raspberry Pi Zero, because it's based on Raspberry Pi Zero, which is around 15 euro. And the software itself is open source. Of course, also Weed Injector is open source and open hardware. What are the main features of POMP? We will see later a bit more in depth, but the idea is that it has Wi-Fi as well, so we can remotely control it as Weed Injector, and it has also USB to Ethernet adapter, CDC gadget from USB protocol. So it can create a Ethernet connection just by plugging in into a USB port of the target machine. It can emulate also USB flash drive file system, so, which is cool. It has the ability to call back a command and control server, so you can be on the other side of the world and control it remotely. Again, able to spoof VID and PID as well. And recently, Marcus added a patched version of the drivers of the Broadcom Wi-Fi chipset in a way that now this little teeny tiny toy is not only Bash Bunny on steroids, but is also almost close to a Wi-Fi pineapple on steroids. So it's really powerful. And lately, during around approximately Hack in the Box, he was working on a new feature that here is the video, because due to time constraints, I cannot show you all the demos. So probably I will publish later even other. So this one was a demo made by Marcus, which is showing a next generation air gap bypass. I will explain you later what it is. Okay, let's go back to with injector. These are the schematics I released and how it's composed with injector. The main two components of with injector are Atmega 32U4. Most of you that played with Arduino knows it because it is implemented in some Arduino Micro Pro and friends. So it's Arduino-friendly microcontroller, and ESP12. ESP12 is known to be used, is the older version of the ESP family. Now, most likely, most of you will know ESP32. Anyway, this type of Wi-Fi chipset are very common in IoT devices, like these power sockets that you can control from a web app, mobile app. So that's thing. Why it's nice? Because in a little small form factor chipset, which is this black thing behind on the PCB, you have what? 4 megabyte flash, NAND flash, Wi-Fi support, both has access point and client mode, and TCP stack and DNS support. So you have plenty of capabilities there. Another thing I wanted to add, and I added in the PCB, is this thing that in Rambler DAC there is not. It's a simple pin-out bridge that is practically giving the ability to the attacker to use the 4 pins of a USB connection to weaponize USB gadgets. We will see later what I mean with weaponizing USB gadgets. And another thing I decided to add was the Hall sensor, because many times when you weaponize a gadget or you plug it in a USB case and you want to unbreak it or reset it or reflash it, it's annoying, plug it in, destroy the USB case, and so on. So with the Hall sensor, you just need to put close a magnet and we'll simulate a button pressed. So I was talking about USB gadgets. What it means? Well, many of you is already aware, and probably you are doing security awareness trainings within your companies about how dangerous is picking a USB flash drive from a parking lot, reception, gas area, and plug it in your laptop to check what is inside. So most of the people now knows that trick, and it's harder and it's getting harder and harder for red teamers, pen testers to prove that is an issue. So another thing you can do is to trick people to think that there are, of course, other USB gadgets on the market that usually raise less suspiciousness. Like, for example, if you see a USB flash drive, you think, there might be a malware there. But if you see a plasma ball or a cup heater, without that cup though, or a fan or a USB beer fridge, I mean, if you see this kind of devices, your awareness will be less high. So in this case, what you can do with by weaponizing USB gadgets, you can test for social engineering awareness exactly as you were doing with the flash drive. You can bypass physical access restriction to a target device because, as I told you, both POMP and with injector have Wi-Fi capability. So imagine, like here, I made an example. This is a fake brochure from a leader's office in supplies. So practically, you weaponize a plasma ball, you pack it back, you take that brochure, you pack everything. Maybe you even create a fake web domain just to give a shape of a more serious operation. Then you pack everything, you send through UPS, FedEx to the target or the receptionist of the company. And then most likely, the guy will see the plasma ball, will think, plasma ball, if he's really smart, he thinks, oh, plasma ball has no data connection. It's just 5 volts. So most likely, it will plug it in. I know I heard people that were using during engagements, and they did succeed, so it is working. So otherwise, instead of Plasma Ball, you can always add a hub, USB hub controller, and weaponize a mouse. Either then you can ship the mouse, or during a physical engagement, you can replace an existing mouse. No one will notice it. And another thing is, but that is restricted most likely to just one person in the world, is that if you are Kim Jong-un and want to have fun pawning international delegates, you have always the chance to do that by giving them USB fans. Of course, we have no one managed to pop open that USB fan, so we don't know if there was or not an implant, but the possibility is still there. OK, I described the hardware part of WithInjector. The software part is the one that is delivered by default with WithInjector is called Exploit v2, which is an evolution of WithGUI. I'm not really a good developer, so a guy, Corey Harding, decided to improve it. So luckily for everyone. So Exploit v2 has many features, like hidden SSID. So for more OPSEC operation, you just hid the SSID, so employees around the company will not see that there is like WithInjector access point there. It has SP Portal Credential Harvester. We will see later what it is. Multi-platform, multi-keyboard language, ability to auto-start, like Rubber Ducky. In case you want to just use it during an engagement with physical access, you can just plug it in and replicates a Rubber Ducky. Ability to change setting on the fly, live payloads, ability to convert. If you already have a list of Ducky scripts for Rubber Ducky, you just need to copy-paste in the web browser once you are connected to the WithInjector, and will automatically convert to the WithInjector syntax, so easy peasy. Ability to update the firmware over there, so you don't need to unplug and play with Arduino if you're not used to it, able to spoof VAD, PID. And the best part, I like it, is ability to bypass air-gapped environments. We will see later a proof of concept about that. Ducky script. So as I said before, if you already have a Ducky script, you just connect to the access point created by WithInjector, copy-paste the Ducky script, and automatically this JavaScript will convert it to the real syntax used by WithInjector. So very easy and user-friendly. This is how to change the layout, language layout, because it's delivered by default with the English keyboard. So like French keyboard and so on. You just need to go in the With repo on GitHub, copy-paste the ASCII map, replace it in put it in the Arduino IDE, and just flash back the USB device. And then you will have a compatible WithInjector for any kind of keyboard you prefer. Here is an example of how to spoof VAD PID. Again, this snippet of code is in the GitHub repo. Here, what we care mostly is the VAD, the PID, and the name. You can put an arbitrary name. Actually, you can use even for fuzzing, probably, operative systems, if you start to play with charge. And of course, it's compatible. Well, here I put as an example. At the end, you just need to add this snippet at the end of boards.txt of Arduino IDE, and then just reflash the WithInjector. So I talked already many times about air-gap bypass. Here is an example. For example, my favorite operating system right now is Windows 10, because it's not complaining anyhow about serial connection. So as soon as you plug it in, poof, serial connected, no drivers, no issues, no nothing. And here is an example. So what you will see now, you will see, OK, in this virtual machine is completely isolated. So there is no Bluetooth connection, no Ethernet connection, no Wi-Fi. It's so-called air gap. This is the full machine, the real laptop, where the attacker is connected through Wi-Fi. So in this case, the WithInjector is plugged in into the air-gapped machine. And you will think, just make an assumption. Somehow that WithInjector got connected. Either social engineering, Plasma Ball, whatever, kidnapping, whatever. So once it's connected, we run a payload. This payload, in this case, is Windows, so it's running a PowerShell script. What we'll do, we'll execute a command, in this case, who am I, take the command, and push it back through the serial connection to the WithInjector. At that point, the attacker will be able to retrieve that information anytime he wants from the web with injector, access point, and ESP flash. So now the attacker is connecting to the default SSID of with injector. Choose the payload. Here you can see the VID and PID used to filter and find the with injector connected. Of course, if you spoof VID and PID, you need to change that part in the script. That was the command who am I. Now, as soon as run the command, of course, can be faster, the injection, but I wanted to slow down just to show you a bit, that is not like, fake proof of concept. So now is looking for the serial, taking the command, and then the attacker is able to see the exfiltrated data from an air-gapped environment. So we fully bypassed. And imagine that the attacker right now could be outside the nuclear implant. So it shouldn't be like, virtual machine. And as you can see, it's matching. Of course, we can do the same in a Linux-based machine. Payload is different, but the idea is the same. So we look for, well, in this case, it's Lilypad, because it's the default name of the, with injector from serial.com point of view. But you can, as soon as you change through the spoofing technique, you just need to change accordingly the script. So what it does is look which serial port is the with injector, execute ifconfig, and set back the serial data. Before I mentioned also ESP port credential harvester. Well, the idea is a very dumb rogue access point. It doesn't have yet the karma attacks abilities like Wi-Fi Pineapple, for example, simply because we figured out that there is a Wi-Fi chipset in there. We can create any arbitrary Wi-Fi hotspot. So we thought, yeah, just let's put it there and let's see if it might be useful for some engagements. And then eventually later improve it with karma attacks. So the idea is that it redirects any HTTP request to some default pages. We can customize up to 3 specific domains, like in this case was like Microsoft.com, Black Hat, BBC.com. So in this case, if the victim connects to this rogue access point and goes to BBC.com, well, we can discuss about HSTS, but in a brand new computer, it goes like, for example, here, you can see that it tries to check if there is, Microsoft is trying to check if there is a hotspot, so it makes a request without HTTPS. So in that case, I'm redirecting. There is also, of course, the catch-all template. So any website you are visiting, the DNS request will be routing you. The reply will route you to my login page, fake login page. So in that case, you can, phish anyone. And of course, all the credentials will be stored in ESP flash. So the attacker just needs to go in the ESP portal, log.txt, and get it. As I said, I'm working on the Karma attack implementation on the ESP chipset. So, well, stay tuned. We'll see. Another software worth to be mentioned is US Abuse. It was developed by Rogan Dapes from SensePost. And the idea is that, as well, is based on Cottonmouth. This is the original PDF leaked by Snowden. Was created, this device implant was created in 2008 by NSA Tau, and practically US Abuse is replicating the same functionalities. The idea, the main feature is the main goal is to bypass their gap restriction. So what it does is, once the with injector flashed with US Abuse is connected to a PC, it creates a Wi-Fi access point, starts a stealthy screensaver killer. So imagine the situation that somehow with injector got connected to your machine. You usually have the setup screensaver set up to kick in after 1 minute, right? 60 seconds. So in that case, imagine that you go to take the coffee and you don't lock your laptop because you know that in 60 seconds, by the time you are to the coffee machine, already kicked in the screensaver. In this case, US Abuse is slightly moving on 1 pixel the mouse, so is emulating a mouse, in a way that the screensaver will never kick in. So in the meanwhile, the guy is enjoying the coffee, the attacker from outside the building connects to the Wi-Fi network and fires the first PowerShell stage, which is what it's doing. It's creating a Hydro tunnel. So human interface devices have different classes. So in this case, it's creating a Hydro, I would say device, but it's better to say tunnel, which is used to exfil data and actually as main channel, communication channel between USABUSE itself and the PowerShell script that is injected in memory from on the target machine. So after this channel is established, it returns a CMD shell to the attacker. If I will have time after the presentation, I will show you how it looks like. This is really cool. And after that, it's pretty much game over. An air-gapped environment compromised outside the building or outside the room remotely like that. What's next? Well, this is with delete. So the idea is the same. It's using, again, Atmega 32U4 as keystrokes injecting device. And as also a USB 2422 controller. What it is just a USB hub controller. So instead of weaponizing a USB gadgets by using an external USB hub, it's already implemented in a PCB. So you just need to solder there the pins that goes like, if it's a mouse, here you put the input from the keyboard, from the mouse, and here the cable that goes to the target machine. So easy. The most important feature of WeDelete is that instead of ESP, this time I replaced it with a, the first version will have a 2G baseband for the simple reason that still many places in Europe and in the world, 2G is still a thing. So, and it's cheaper, this baseband, than this one. The second version I started already to work on, so it's just a matter of, because both of them communicate on UART, so serial connection with Atmega. So it's just a matter of redesigning the PCB a bit. So the second version will have an NB-IoT baseband, so LTE. So everywhere in the world is supposed to work flawlessly. So how it works already, the workflow from this new device? Well, the idea is that the attacker sends an SMS for in some way WeDelete was connected to the target machine, of course. So it sends an SMS like do air gap, who am I? WeDelete take the command, inject, makes a keystrokes injection into the target. So in this case, like that PowerShell script I showed you before with injector, almost similar code, with who am I command in it. WeDelete waits for the answer back of who am I output, takes the output, in this case, Contoso Alice, and sends back through SMS to the attacker. That can be potentially on the other side of the board, because again, weaponizes plasma ball and then can ship through FedEx everywhere around. So this is an example. What you will see is a laptop, completely, again, air gap, no connection whatsoever. And that keyboard was weaponized with WeDelete. So as soon as you plug it in, it takes a few seconds to boot up, connect to a 2G network, and then it's pretty much operative. Here from the command and control, well, from an SMS you send like who am I in do air gap mode, so we will get back the output of that. And then the SMS flies, goes from the mobile network of the attacker, mobile network of WeDelete, and then start the injection, take the output, sends through serial, and then WeDelete will send the SMS back with, as you can see, with who am I output. And of course, he's sending also an acknowledgement about command received, because in case you just want to inject like a PowerShell Empire stage, like you don't need like output. So it just send you an acknowledgement that was executed. And here is the classic calculator. So as you can see, no output back, but just acknowledgement that was executed, just to be sure that it was received and executed. Another thing I added, well, since we have a GSM or anyway a mobile network basement, we have microphone capabilities. So I thought, yeah, why not? Acoustic surveillance. So by adding a microphone, we can easily like make call, send the number of the attacker or anyone that wants to be called from with delete. With delete, we receive the command, start enable the microphone, and then start the acoustic surveillance by calling back the attacker control number. So you will be able also to listen conversation around. That's not enough. I was not satisfied enough about the capabilities, so I wanted to add also a NRF chipset, 24L01. And what it does, well, most of you most likely heard it about, Crazy Radio, the ones that loves to use drones, you can use with drone hacking. But in this case, mouse jacking wireless keyboards and mice. And I will show you now what it means. So imagine like that you manage to, with delete gets attached to a victim, and then you want to hunt for his colleague wireless keyboards or mice. So in this case, the usual calculator to prove that we can send and receive back information. And here the payload. Well, in this case, after do mouse jack, right now was, I wrote full because it doesn't matter what you write. At the final release will be like a number of channel hops or seconds, it doesn't matter. And now we start to scan. So imagine like another target with another machine is using the mouse or the keyboard and generates traffic. So in this case, we delete, sees the traffic, follow the hopping, and then inject keystrokes. So again, I try to inject keystrokes and succeeded. In this case, for proof of concept, I use the same laptop. But the wireless keyboard should be connected to another victim, of course. Another thing I'm working on is hybrid command and control. So not only SMS-based, but because SMS has the 140 charge limitation per SMS, so exfiltrating data is not that reliable. So the idea is attacker sends an SMS like, who am I, to we delete, inject the payload, get back the output, and instead of sending back an SMS, is uploading through HTTP, making an HTTP post to a C2 controlled by the attacker, and then sends an acknowledgement to the attacker through SMS again, and then the attacker knows that you just need to visit the exfil.txt and will be able to get like Mimikatz output instead of something else. Another thing I'm working on is the with mobile connector, because someone said connecting every time to the Wi-Fi access point, visiting a web browser is annoying. So this is what I'm going to what I'm going to release next is a config UI. Able to, once you set the first time, will be able to auto-connect to the access point, so you don't need, as soon as you open the mobile app, will connect. And then most other important thing is that the payloads will not be stored on the ESP device of the injector, will be stored on the mobile app. So it will be a pain in the ass from blue teaming point of view how to retrieve those payloads, because will not be stored anymore there. Another thing, as I mentioned before, I would like to bring karma attacks to the ESP chipset. So in this case, will be not only a rubber ducky on steroids, but a little brother of Wi-Fi Pineapple, which is always good because the hardware is the same that you already have. Short, brief discussion about PwnPy. These are the main feature, bypass air-gapped environment, as we saw before, Windows 10 log picker, and Wi-Fi cover channel. The Wi-Fi cover channel is the best feature. I love it. Practically enables the keystroke injection, bringing up the USB head tunnel, that the same head row tunnel US Abuse did, then delivers a .NET library client via the HAD tunnel into memory, and then invocates net library from PowerShell, and then it's done. The attacker needs to remove the PwnPy, walk away, and then the target machine will try to connect to the command and control server of the attacker within the POMPI, and then everything will be done in a hidden channel through the probe request of a Wi-Fi chipset of the victim. So in that case, the victim will not need to connect physically to the POMPI access point. It will be all probe requests, so the victim will not notice anything. Here are some videos, because I have no time to show you, but it's a really cool thing developed by Marcus. There are two operational modes of POMPI on premises, so the attacker connects outside the building, outside the room, to POMPI, or otherwise POMPI can call home. As you can see, here is one module I added to the Raspberry Pi with a GSM baseband, which can call you home, your command and control server, wherever it is. So you don't need even close access to the building. Here a very short demo how it works POMPI. So in this case, again, air-gapped environment, fully protected. The POMPI got connected. And now the attacker connects to the network. Okay, the attacker is connected to the POMPI network, Wi-Fi network, and then fires the first stage, which is a PowerShell script. And then it fires the second stage, called shell. And boom. Full usual shell remotely connected to an air-gapped environment. So we didn't need, this air-gapped environment doesn't even have Wi-Fi network enabled. So full remote shell like that. These are some other mods around available with, if you like to play with electronics, really cool. Some mitigations, well, the most important is don't trust the non-USB devices, ever. If you want really to trust them, just use a USB condom. So just, you can buy it, like SyncStop, or you can make it. Just cut off the data cables of a USB cable. And other kind of mitigations, well, here I suggest you to make a photo or check out the video later, is practically what you do, you use dev rules to restrict access, restrict the creation of new, registration of new devices on Linux, or if you're lazy, you can already use open source tools to achieve the same idea. For Windows, there are open source tools as well. I like Duck Hunt because I have 4 different operational modes. So depending on what you want to achieve, you can be super paranoid or just log any new devices connected. And here are some artifacts for blue teamers here, incident responders. Here are most likely, you already know, most of them. These are some places where you can find information about key devices connected, timestamp, and so on, VAD, PID. So here is an example. This is the first time device was plugged in. Here we have a tool, freeware tool called ESB View, which shows last time plugged, first time plugged, and actually in here, if you're smart enough as Blue Team, you can even check, sometimes you can spoof VAD and PID, but there are other IDs on a USB device. So like firmware version, tons of them in descriptors. So if you're a bad attacker, you can spoof VAD and PID, but you can forget about firmware version. So a forensics guy can use these kind of logs to check if was inserted a real HP keyboard or a spoofed one. Another thing that we can find on Windows 10 and since Windows 10 and Windows 2016, Windows Server 2016, is this group policy, is these policies, audit PNP activity. Once this policy is enabled, every time you plug it in, a human interface device will trigger the event 6416, which is called a new external device was recognized by the system. This is very good because it's giving a lot of information like device name, class name, VID, PID, timestamp. So it's always good, especially if you use Sysmon and Splunk and all these, detection system, even remote sending remotely. This event log is very good for detection. Of course, you can also do advanced forensics, like a very simple thing. Imagine that Blue Team finds or get access to one with injector, for example, just plug it in a Linux machine, and just by using the default ESP_tool.py, you can dump the image of it, of the ESP NAND. And then you just need to run strings, not even idle or stuff like that. And you can find exactly what was stored. In this case, was the ESP portal credential harvester that the attacker successfully retrieved information from a poor guy that fall victim. And then you can even see attackers' information like SSID, password. In this case, are default credentials. But imagine like an attacker that changed them and fails on OPSEC. And maybe you can correlate by using OSINT, by finding, maybe you will figure out who was the attacker. Of course, you can also dump Arduino firmware. It's an AVR controller. So you just need to dump the firmware and then try to reverse engineer it with Radar. So a bit harder than using strings and ESP tool to dump the image from ESP, but still not that bad. Well, here are some resources. And I guess I'm pretty much done. I don't know if I have some minutes for questions. Five minutes? We have 5 minutes. Anyone has questions? I don't see. One guy there.
Is there any way to detect user activity to avoid launching scripts when he's in front of the screen or typing on his keyboard or moving his mouse, for example?
I heard just half of it. Is there any user activity?
Is there any way to detect that the user is active to avoid launching stuff on his screen while he's in front of it?
So you're asking if the user can detect the activity, or wait, because...
Well, in your demos, we can see that the device is opening the execute
yes,
and then
running. Yes.
So
there are some, actually, for example, in PowerShell, there are 2 lines of code that what they do is, for example, one line makes the background color the same color of the font, and then another line takes down the entire window. So it's a matter of 2 seconds. Okay. So usually that's the difference between Rubber Ducky and with injector or PwnPy. In this case, what I would do is, well, usually I don't care about these 2 seconds, 3 seconds of activity because the user is already compromised at the end. I mean, afterwards. Of course, if the user is smart enough and sees something flashing around, we'll call the blue team. Usually I triggered when I know that the victim is around. So imagine a receptionist. So I call the receptionist, and then I trigger when she's not looking at the monitor. So in that way, but yeah, of course, I mean, this kind of attacks relies on the fact that can be detected. I'm not saying that are undetectable. Though it can be reused, it can be used this trick of background and font color the same, and then reducing after a few seconds. For example, in PwnPy, the video I showed you was what, 2 seconds, the first stage. Let me check. So yeah, it is possible. Right here. You can you enable the? Okay. Okay. Look now. 1, 2, 3. 3 seconds. It can be improved. This is the default one. So yeah, of course, can be detected. I'm not saying that if you are fast enough and you're. I mean, I bet that HR employees. I mean, because we are IT security guys. So if you see something like flashing, you immediately raise an alert. But usually, them is like.
Thank you.
Thank you. Yes.
Hi.
Hi.
Thank you for the presentation. I like to complete the question of my friend over there because the stealth is one point, but the other point is that the user has to stop using any HID device during the script injection. So in fact, it's not only stopping, not noticing something is happening, you have to stop using your computer, in fact.
Yeah, technically this overlapping, it might be an issue. But
Yeah.
as I said, usually I tend to remotely inject when I know that, for example, US abuse is using the trick of the screensaver killer. So in that way, is attacking the attacker will trigger it when he knows that the guy is not around.
Yes.
There are some means, like for example, if you are into hardware hacking, you can add like a photoresistor. The photoresistor will detect, like for example, if you weaponize a mouse and you add a photoresistor on that, you can use that matrix. So, photoresistor, the light is changing the value. So you can use that as a metric to see if the guy is around or not. So that can be a way.
Yes. Can I just complete another question, maybe? Are you planning to work on a dynamic VID, PID spoofing? Because I see that in that way you have to somehow compile the firmware with the VID and PID.
Yeah, I understand the thing. The thing, that VID, PID spoofing was mainly for engagements where you have the recon phase available. So you walk around the building and you see a lot of standard Lenovo keyboards. So you go back to your company, office, wherever, and then you buy a Lenovo and weaponize it. And then you manually reflash the firmware with spoofing a VID, PID. Dynamic VID and PID spoofing could be doable because RaptorDuck is doing that from, you put that file in the SD card and is doing that from that side. I never investigated that. I can investigate. I will. Yeah. I can put that as an enhancement in GitHub. Thank you.
Thank you.
All right. Thank you very much.
Thank you.